Okay, guys, we discussed number 3 now. Rubber balloon, inflated helium, blah blah blah. Immediately, heaters are switched on, blah blah blah. In the room increase. When the heater are first switched on, the temperature immediately below the ceiling increase more quickly than the temperature of air in the rest of the room. Explain why this happens. Temperature below ma? Because where you place your heater? You place below ma? Okay, so it will hit the air at the bottom first. Yeah. Yeah. Okay. Convection also got. Convection also got.
So you mean below the ceiling as right there only?
Yeah. Below the ceiling increase more quickly. Oh, yeah, below the ceiling only. For example, the question asking is like this. This is a heater, right? This is a ceiling. Why the air right below the heater is faster compared to the side? Like why not here? Why not here? Why must be exactly below the heater? This is because of the convection. Okay, get it?
Right.
Okay. So how you explain this? You said the heater transfer heat energy through convection.
I cannot see the heat air rises, man.
Can. Haven't finished explain ma.
Oh,
You mentioned convection first ma. Then you explain how convection, how the convection works. Convection is convection. Yes. Okay. You said the hot air from the heater rises ma. Okay. And then the cold air will sink. Okay. So you said the hot air from the heater. Actually, no. Do you need to write from heater? No, right? Okay. So you said the hot air rises, and the cold air. Okay. Sink down. Okay. Because okay, why it will rise and sink? Remember or not? Hot air is less dense than cold air.
why is it less dense?
Because they expanded. Remember, you heat something to expand. Expand means volume increase. Volume increase, density will reduce. Okay.
Expand.
So B, temperature of helium increase as the rubber stretches, the volume occupied increases. Say what happened to the motion of helium particles as temperature increases. This one should be easy, right? Increase temperature, the particles will move faster. Yes. Yes. Okay, you see the particles move faster. Yeah, very simple. Next, as rubber stretches, the volume increases, the pressure is constant. In terms of the particles of helium, how pressure remain constant? So how? Okay. So this one,
Also, the helium move faster, is it?
P is inversely proportional to volume. Yeah, P inversely proportional. But this one they increase temperature, so it's like this. Increase temperature, the pressure increase, right?
They don't say the temperature increase.
Got. Linking together one. See or not? Okay, temperature increase, pressure increase. But at the same time, because you increase the volume of the balloon, volume increase, pressure decrease. Inversely proportional, PV.
I thought it says constant.
Oh wait, shit. Pressure, yeah, constant is because it's like this. If your volume increase, pressure reduce, right? So just now the temperature increase, the pressure increase, right? So one factor make it increase, one factor make it decrease. So increase degree cancel off constant. This one. No formula. This one is your general knowledge. Okay, I just show the answer. Okay. So at first, okay, high temperature.
High temperature increase the pressure. Volume increase the
Yes, this is what I'm going to write. Okay. High temperature, the particles collide more frequently. Okay, so the pressure should increase, right? Okay, so the pressure should increase. Then the next one is the volume, right? So volume increase, what happened to the pressure? Okay, you say the particles first. The particles collide less frequently, right?
volume increase,
You have to run further away. Like originally, small volume, let's say like this, I can keep collide like this.
Oh, 这个是那个 collision theory.
Yeah, collision theory.
Oh.
Remember collision theory? Like you have to travel further for collision. That's why the collision rate reduced.
Collide less frequent.
Due to high pressure. Yeah. Okay, so volume increase, less frequently the collision, so the pressure reduce. Okay, so you say the effect of the high temperature and larger volume cancel off each other. Okay, cancel off each other, so the pressure constant. Holy shit, so long, 3 months. Okay, so show the increase in the internal energy was this much. So Q equals to MC theta. Yeah. I don't remember, damn funny. 600 divided 1000, change to kg, okay? The C4200 theta, the reading is 19. At the end, it's 29.5, so 29.5 minus 19, okay?
哦，我在被妈多走一次，就是关那个门太大力了。
Seriously?
就是。
Okay, so you get 6,300 joules.
好大我啊，进来。不是，那时候是另外一个。哦。
Okay 啊。
另外一个什么？进来骂你啊！我忘记是进来，你知道吗？你发的嘞。 没有，因为我真的是关很多次，很大力来试多次啊。
还好意思讲。Okay, guys. B in the experiment, the lamp is switched on 500 seconds. Okay, power supply is 13 volt. I mean 13 watt. The usable energy is transferred as light. Increase is wasted energy. Okay. Find the maximum possible efficiency of the filament lamp. Yeah, the power supply means it's your input. Okay, so how you find output? Output power, so what is the wasted energy? It's 6,300. Wait, this is not output. This is the wasted energy. Wasted. No, whatever. Wasted power, okay? Wasted power is how much? 6,300 divided by the time taken 500 seconds. I don't trust you, man. Okay, you get 12.6. 12.6 watt. Okay, so what is the useful output? You need to minus. Okay, because we're calculating for efficiency, you need to find what is the useful output. Okay, so the output power is you need to minus input is 13 minus 12.6, yes, you get 0.4 watt. So efficiency 0.4 out of total 13 times 100%. How much?
Like 5%. That's about.
Yeah, man. I don't trust you, man.
0.4.
3%, I want 0.4. I get 3%. What the hell?
3%.
Yeah, 3%. Okay, 0.4 divided by 13 times 100. Yeah, 3%. What the hell, man? Okay, efficiency of lamp is less than the value determined in A2. So remember, because in real life, there's always energy loss. Okay, so this one you can say like some energy is transferred to the like lost. Some energy is lost from the water. Okay, like some heat energy is lost, okay, from the water to the beaker, for example, because the beaker heat up together also. Or you can say like the water, some water evaporate also can. Okay, some water that evaporates, so it affects the result also. Okay, some water evaporates.